Hello, in today's video we're going to be talking about the mole. So what is a mole? Well, let's say that you're going to go to a store. Let's take a simple example. Let's say you're going to the store and you want to pick up 12 eggs. You generally won't tell your roommate, "Hi roommate, I'm going to the store and I'm going to pick up 12 eggs. You'll generally say, "I'm going to the store and I'm going to pick up a dozen eggs or a half a dozen eggs or 2 dozen eggs. That dozen is a way of grouping a certain number of those eggs, and we know that for 1 dozen there are 12 eggs. Same type of thing is going to be happening with the mole. Now, in order to convert in and out of the mole, we're going to be dealing with a number, a special number in the world of chemistry called Avogadro's number. Avogadro's number is denoted by a capital N subscript capital A. So this is Avogadro's number. And Avogadro's number has very specific and special units to the world of chemistry. Avogadro's number is equal to 6.022 times 10 to the 23rd, and in this case it's going to be entities. We'll talk about what entities are a little bit later, per mole. Now you see up here I wrote mole M-O-L-E, and down here I wrote mole M-O-L. This is generally how scientists will write the mole when dealing with units, but this is how we write when talking about the mole. So both are correct. You can write an E here if you wanted to, but this is the general standard notation. So this is Avogadro's number. Now what are entities? Entities can change based on what you're talking about. So let's say we're talking about atoms, the entities can become atoms. So Avogadro's number can calculate atoms per mole. So we'll talk about what a mole is. It can also calculate molecules. It can also calculate ions. And it can also calculate things known as formula units. This comes into play when we're dealing with compounds, ionic bonds. That's what we call a formula unit. We know that molecules come from covalent bonds. So we don't want to keep writing out formula units, that's a long word, so I'll denote that F.U. And that stands for formula units in the world of chemistry. So these entities can change based on whatever we're talking about. So let's look at an example. Let's look at an example of 5.5 moles of carbon. Now I'm going to work this calculation 2 different ways. On one side, I'm going to convert into atoms and actually count the number of atoms. And then on the other side, we're going to use the molar mass that's given on the periodic table to calculate the actual mass in grams of 5.5 moles of carbon. So let's do that first. Let's multiply backwards. For every 1 mole of carbon, there are 12.01 grams of carbon. We know this specifically from the periodic table. So here, the moles are going to be able to cancel, and we're going to be left with grams. If I have my cheat sheet here, that's going to equal 66.055 grams of carbon. So that's what 5.5 moles of carbon equals. We can multiply by the molar mass, which is given on the periodic table, and we end up with a mass. So what this says is for every 66.055 grams of carbon, we actually have 5.5 moles of carbon. And of course, in this case, the 66 would only be 2 significant figures. There are only 2 significant figures here. Now, let's convert from moles of carbon into atoms of carbon. And we do this by multiplying by Avogadro's number. For every 1 mole of carbon, there are 6.022 times 10 to the 23rd. And in this case, we're talking about carbon, which we know comes in atoms. So this is going to be atoms of carbon. Here, the moles of carbon cancel. I'm going to pick up my cheat sheet again, and we're going to end up with 3.3121 times 10 to the 24th atoms of carbon. So I'm drawing a demarcation line that separates these two. So in 5.5 moles of carbon, there are 3.3 times 10 to the 24th atoms of carbon. This is why we have this idea and this unit of Avogadro's number. It's so that we can write out a large number in a very small, to convert a very large number to a very small number. But this also is able to relate atoms to grams. So now we know in 66.055 grams of carbon, there are actually 3.3121 times 10 to the 24th atoms of carbon. So now we can go into the laboratory, we can take a gram, a mass of any compound or element, and we can figure out how many atoms, molecules, ions, formula units are in that mass. This is very useful in the world of chemistry, and we'll talk about and we'll perform a lot of calculations tomorrow in class. With that, I want to say I'll see you all in class tomorrow.